Hi, on the workbench today, I have another bench switching power supply. And this one is the BSIDE I84020. The model number 4020 indicates its maximum output voltage and maximum output current. In this case, the power supply is capable of outputting up to 40 volts and can supply a current of up to 20 amps. Of course, it cannot output the maximum current at 40 volts, as this is only a 300 watts power supply, so the maximum current under any given output voltage would be limited by this maximum power dissipation factor. Of course, if you do the math, the maximum current of 20 amps is only achievable at an output voltage of 15 volts. Of course, we will test it out further in this video. Banggood provided me with this power supply. As usual, I will leave a link and coupon code in the video description below for those who are interested in getting one after watching this video. And I have reviewed quite a few of these entry-level switching power supplies on my channel, and I will provide links to those videos below as well, in case you wanted to do some comparison yourself. Besides the i84020, Banggood also has a couple of other versions, for example the i83010, which is the 30 volts and 10 amps version, and the i83005, which also has a maximum output voltage of 30 volts, but the current is limited to 5 amps. On the front panel here, you can see we have a physical button, which is definitely a welcome feature. And if you recall, on some of the power supplies, the one I can remember is the 011, that the physical button is actually located on the rear here. And that is not ideal because if you put it on a shelf, you wouldn't be able to access that button very easily, but not the case here. And here are the two output binding posts. Now, we only have two of these posts here, so I'm assuming the output is not earth referenced. Let me actually check it out. So here I have the continuity mode. So that's the meter here, and you can hear here is continuity. And I'm going to check the earth pin here to see if we have any continuity. Nope, you can see that it is not connected to the chassis with earth ground, so it means that the outputs are actually isolated from the ground. Now, it would be nice to have a dedicated earth ground binding post here, as sometimes it is required under certain testing circumstances. Also, as you can see here, we only have a single rotary encoder here. Not sure how well it shows up as everything is black. So I assume it is multiplexed for both the current settings and voltage settings. We also have a USB port here for charging on the front panel. It just offers a standard 5 volts and 2 amps output. Nothing fancy, but can definitely come in handy. Now, it seems that most of the bench power supplies these days offer USB output now. It is even included on some of the lab-grade power supplies, like the Unity UDP3305S I just reviewed. Anyway, let me flip it over and take a look at the backside here. We do have a USB port back here, which I assume you can use it to connect to a computer and control the power supply remotely. This feature could be useful in an assembly line setting to perform some automated testing. But for typical lab use, you most likely won't need it. But it's good to know that this power supply supports it so that you could use it if you have the need. And also you can clearly see the cascading here, as the model number is just a sticker that is slapped onto the back of the case here. As I have mentioned many times on this channel, a lot of the Chinese products share the same underlying design and are sold under different brand names. So I wouldn't be surprised at all if you find the exact power supply design, but it's sold under different brands. Anyway, let me connect the power cord here. Oh, by the way, not sure if you can see this, we do have this switch to switch between 110 volts and 220 volts. Now, you need to be very careful and double check the voltage settings here, as otherwise it could ruin your day if you set it wrong. Now, in the United States, I guess we're lucky, as the worst case would be somebody left it to 220 and the power supply simply just wouldn't work. But if you are in a country where the power supply voltage is 220 and you set it to 110, that could be a big problem. Anyway, let me plug it in and we'll take a closer look here. Oh, of course, the screen protector is still on. We can easily fix that. And it only took a couple of seconds to power on. The UI is actually pretty intuitive. You have 3 of these preset buttons you can set to preset voltages. And you can see I had 3 set up already, 5 volts, 12 volts, and 18 volts. With these 3 presets, you can actually set the most commonly used voltages that you use in your lab. And let me show you how that is done. You come to the menu, and you can see here we have 3 of these presets. Let me zoom in a little bit more. And you can come down here. For example, if the first voltage we want to set is, instead of 5 volts, we want to do 3 volts. That's 3.3. Let's go here. And you can see 3.3. And we can, of course, set the corresponding current limit accordingly as well. So in this case, for example, if we want to set to 3 amps, you can do that. So that's actually how you set the presets. Of course, the settings are not just limited to the preset values. You can also come here. For example, now we want to change it to, let's say, 18.5 volts. And you can set it that way. No problem at all. And the designers clearly had put a lot of thoughts into the design of this power supply. For example, right now we set it to 18.5 volts. If I power off the power supply and power it back on, you will see that it actually remembers the prior setting. So that's actually a very nice feature. I think the first thing we're going to do is to take a look at the voltage and current set accuracy here. And by the way, the unit does come with these banana leads. And these are relatively good quality, but they're a little bit on the thin side. And I think it's probably only going to be good for up to 3 amps. So we're not going to use these in today's test. We're going to use our own. All right, I had hooked up my trusted UT61E Plus multimeter here. And let's take a look at the output voltage first. So right now, let's go back here. Let's set it to, actually, let's do 1 volt here. Let's go down to 1, and let's turn it on. And you can see we're pretty much at 1 volt here. Not a problem. I do see now we have this seconds display here. I'm not sure what is the intention here, but it's kind of annoying. Now that said, right now we're at 1 volt. Let's actually change it to, let's say, 2 volts. So you can see the ramp up time is actually quite slow. And we'll have to take a look at that a little bit later. But right now, 3 volts, 4, 5, and it looks like it's relatively accurate here. So let's actually go to 10 volts here. You can see no problem. And we are going to 20, 30, 40. Yeah, looks like the voltage setting is pretty accurate here, without any load, that is. Now, let me power it off. Let's see if I turn off the output, what the behavior looks like here. So now I turn it off. And you can see there's a really slow ramp down. So that means we have a relatively large output capacitor here, which probably is not the ideal situation, as you don't want it to store a lot of charge when you have the unit powered off already. But that is, I think, what we're seeing here. So let's power it back on. So now I'm curious to see if I, let's say, change the setting when it's powered off to, let's just say, 1 volt, and what the behavior is when I power it back on again. Let's do that. And I need to be quick here because it gets discharged pretty easily. So let's do this. I turn it off and I quickly change this to, let's say, 10 volts and power it on. And you can see that we are essentially dropping to that voltage. So clearly, if you have the voltage change, especially change to the downside, you need to be careful, as it does take some time to discharge the output. All right, so now I have swapped the leads, so we're measuring current now. So let's take a look at the current setting accuracy here. So right now, the output is set to 1 amp. Let me enable the output. And we're pretty much at 1 amp, which is good. So let's change it to, let's say, 2 amps. Yeah, actually it's pretty good. 3 amps, you can see that. The current setting accuracy is pretty spot on. Now we're at 5 amps, let's just do 10 amps. And you can see no problem at all. So of course right now it's in the amp range. Now I'm curious to see if we go back to, let's say, let's do maybe 50 milliamps. And let's see what the accuracy is like. And it's, you can see, still pretty spot on. Let's do 100 milliamps. And of course, let's actually change it to milliamp range here. And 100 milliamps. So you can see that we do have some residual current even when it's powered off. Now we're in the milliamp range. You can see that. We also set output to 100 milliamps. So let's give it a try. And yeah, like we observed before in the amp range, definitely the accuracy is not as good, but that's to be expected as we're right now kind of at a very low end here. So let's actually change it further down to, let's see here, to 10 milliamps, which is the minimum resolution here. And yeah, you got that constant 5 milliamps offset here. So just something to keep in mind. Of course, that is not something you typically do, and the current limit is really just for limiting the current rather than using it as constant current power supply. Next, I want to take a look at the power on characteristics with and without load. So first I want to test it without load. And right now the output is set to 2 volts, and of course the current, I'm not going to limit it, so it's at maximum 20 amps. And right now I hooked up the output to the oscilloscope. You can see here the power is off. Of course, I can see already some noise. Not sure if you can see that. There's definitely some switching noise going on here, but we'll take a look at the noise a little bit later. So right now we're just going to concentrate on the power on characteristics. Let me actually change the trigger up a little bit more so it doesn't get false triggered. Okay, now let's do a single shot. Yeah, so the trigger level is too low. Let's do it higher here. So do a single shot, and I'm going to turn it on. So you can see without any load connected, the rise time is roughly at 15.5 milliseconds. And as I mentioned earlier, you can see there's significant noise on top of that waveform. Anyway, so let's remember this number, 15.5, and let's do it again with a resistor connected. So this is a 5-watt resistor, 10 ohm, so we're drawing some current here. The idea is to put some load on it, and let me set it up. Let me turn the output off first. Okay, so now we have set it up. You can see it's measuring the resistor here. So let's now do another test. And you can see the rise time is essentially the same. Now we still have some noise, but of course the noise is quite subdued because we now have a load here. So the power on characteristics is pretty clean for this power supply. Let's actually do it again. Let's enable the output. And you can see here is the power on curve. Now we do see a tiny spike here, but that's probably just noise and it's not really that significant. Now let me take a look at how the overcurrent behaves, because right now we're not limiting the output current. For the next test, I'm going to see how well the current limit works on this power supply. So you can see, let me just zoom in a little bit. You can see that we're currently setting the output to be 5 volts now, and the current limit is 0.1 amp. So with a 10 ohm resistor, obviously the resistor is trying to draw 0.5 amps. So we'll see how the power supply copes. Now let me do a single shot, and let me enable the output. Now, because we're limiting the current to 0.1 amp, given a 10 ohm resistor, the maximum voltage should be 1 volt, but you can see here the maximum voltage reached was 1.26 volts. So that definitely overshot by about 26%. Of course, the voltage actually started ramping down. Now, that's actually not significant, so that's actually not a bad run at all. So let's do it again, and let me change a few of the settings here so we can see it a little bit better. So let's see here, and we will start running again. And there's some funny business going on. You can see we actually have, looks like some kind of ringing here. So let me actually tighten up the time base even more and to see if we can see it better. Of course, we can always move the trigger point to the left so we have more space here. Okay, so let's start the sequence. And you can see we definitely have some ringing at the beginning here, but eventually it settled down on that 1 volt. You can see amplitude is 1 volt. So let's actually take a look at what time it took to do that. So let's see here. It looks like it took about 150 milliseconds for the output to settle down. So let me zoom in a little bit more. You can see it. So we can do it again. This time, let's actually get rid of the cursor. Let me expand a little bit so we can see it more clearly. And let's do it again. And you can see that we have this little bit ringing here. We overshot by about 20% and then undershot it by about 5%. And then we eventually get to this final stage of 1 volt. So given this, it's actually not that bad, especially considering the price point of the power supply. What I'm going to do next is take a look at the over voltage protection and over current protection. Currently, these are set to be off. So to enable them, by the way, you can come down here and, for example, let's actually take a look at the voltage here. So let's say we want to turn on and off. You can use the up and down button here to turn it on and off. So let's actually say we wanted to set it to, let's say, 5 volts, the over voltage protection here. And we want to set it on. And now let's come down to the over current. Let's say the current, we're going to set it to 0.5 amps. Let's do that. And also we want to turn it on. So this time we're going to set the voltage to, let's say, 10 volts. It will try to draw 1 amp, and we're going to limit the voltage here. We're going to limit the current here, rather, to, say, 2 amps. We'll probably try to do too many things at once, but let's actually take a look at what the output waveform looks like, and we can always adjust the settings here. So let me change it down to here, and let's tighten up the waveform. Do a single shot here. Looks like this one is out of range. We'll do it again. And tighten it up further. Let's do this, single shot. So from this capture waveform, you can see that the over voltage protection and over current protection doesn't actually work as well as the current limit that we saw earlier, because the output is set to 10 volts and over voltage protection is set to 5 volts. And let's see how long it took for it to drop down here. It took about almost 300 milliseconds for the voltage to come back down. Of course, now we also have this current limit at 0.5 amps. So let me actually get rid of the current limit here, because I want to just see from an over voltage perspective how fast the reaction time is. So let me come back here to turn off the over current protection, and we'll run the test again. So to eliminate some of the uncertainties, I actually turned off the over current protection. Now we're only using the over voltage protection. So the over voltage is set to be 5 volts, and right now the output is set to be 10 volts. So when we try to power it on, obviously that will cause an over voltage situation. So let's take a look at the output again. And you can see we're getting similar curve here. So the output is not ideal as it ramps down very slowly. And we do have this 10 volt full output for quite a bit of duration here. So let's see what that is. Sorry, let me try to move this one. Sometimes it's a little bit difficult. So we're talking about roughly, for a good, you can see 100 milliseconds, the output is actually 10 volts. And of course, it takes quite a bit for the output to ramp down. So it took half a second for it to go back down to 1 volt. And now let's leave the overcurrent protection on only and see what the behavior is. So we're going to turn off this. We're going to turn on the overcurrent set to 0.5 amps. So let's give it a go. And you can see the output is very similar. And just for completeness, now let me enable both again. So we want to see if that is a factor here. And I don't think so based on what we saw. But let me come back here, enable the over voltage, and both over voltage and overcurrent are now on. So let me try to do that again. And you can see the output is very similar. Of course, the duration here changes ever so slightly, but nevertheless, the overall cutoff behavior is quite similar. And of course, we want to take a look at the repo of this power supply. And for that, I had set the voltage output to 5 volts and maximum 2 amps and turn off the over voltage and over current protection. I'm still using this 10 ohm resistor as a load. So this is going to be a little bit difficult to capture as I will have to measure very close to the base here. And currently you can see I set the scope to be AC coupling and the output is at 10 millivolts per division. Of course, we're using a ×1 probe here. So let me get it situated. Before I power it on, I just want to show you the waveform here, if I can get it. And you can see that even though the power output is off, we are still seeing the switching noise coming through because it's not a relay at the output. So you are still going to be able to see that switching noise as the power supply is still working. You're just not outputting anything. You can see that here. So now let me actually turn on the power supply. And you can see that we're not seeing any appreciable differences in terms of the ripple noise here. So that's actually pretty good. So let's actually turn on the cursor. Get it back here. So we're seeing about roughly slightly less than 10 millivolts. From the measurement we're looking at here is 7.8 millivolts. Actually, that's not bad. Alright, now we're going to do some load testing. For that, I'm hooking up the power supply directly to the electronic load, as you can see here. And also I'm using the Unity to monitor the output voltage directly from the connectors here. So at least we can see what the power supply's output voltage is at any given moment. So let's give it a go. And by the way, first I'm going to start at 1 amp. You can see here, that's the load current setup. And I had already disabled over voltage protection and over current protection. And also right now I set maximum output to 20 amps so that we don't have any interference from all these other settings. And right now the output is set to 10 volts. So let's actually enable the output here. And you can see we're reading 10 volts, no problem. And now let me turn on the electronic load. So right now we're drawing 1 amp. And you can see the voltage dropped a little bit as we're not measuring directly to the base. So that's perfectly acceptable. So let's increase the current here. So let me enter. And we want to do 2 amps, 3, 4, 5. Let's go to 10. Right now we're drawing 10 amps. And you can see here, we're drawing 100 watts out of the power supply. And everything looks still pretty good. So let's actually draw the maximum 20 amps. Now we're at 20 amps. You can see the voltage drop to 9.857. That's again because we are not quite at the base, but still this is okay here. And you can hear the fan from the power supply already kicked in because we're now drawing 200 watts. So I'm going to increase the output voltage from the power supply to say up to 15 volts as that's the maximum dissipation of the power here. So let's come here to volt. And let's do 11, 12, 13, 14, 15. And no problem at all. We're at 15 amps. We're at 20 amps rather. I'm curious to see what's going to happen if I start to further increase the voltage here. So let's do that. 16 volts. Nope, we're not able to increase the voltage anymore because it detected this is actually the maximum power it can dissipate. So that's actually good. So now let me turn off the load briefly. And I'm going to turn off the output. So now what I'm going to do is I'm going to set it to the maximum voltage here. So the voltage maximum. Actually, you can see that because we're set to 20.10 amps, we cannot actually change the maximum voltage here. That's good because the unit internally had calculated what the maximum dissipation of the power is, so to limit you entering any invalid settings. So let's come to the current here. Let's just drop it down because I don't know what the maximum current is. So let's actually change it to 1 amp for the time being, and we come back here to set this to the maximum voltage here. And then we go to the current. We should just be able to dial up until it does not allow us anymore. So yep, so you can see here, if we are setting the maximum voltage to 40.5 volts, the maximum allowed current would be 7.48 amps. So let's actually test this condition here. So let me enable the output. And let's turn on the electronic load. So we're not able to draw 20 amps, obviously. So we have to come back here. Let's do enter. Let's do 7.2 amps. And you can see, besides some voltage drop here, everything else looked pretty normal. And I'm going to let it run for a few minutes like this to see if anything gets hot. Alright, as you can see here, we have roughly run this for about 5 minutes now, and nothing is super warm. In fact, I just took an IR image of the power supply, and you can see that it is not that warm at all. In fact, it feels pretty cool to the touch. So that's actually pretty good. Unfortunately, I wasn't able to open up the unit. I was going to do a teardown, but looks like I'm not able to do that today. And you can see I was only able to remove a couple of these screws, and it ended up actually breaking off the bits from my screwdriver. Not sure if you can see this, but it had ruined quite a few of my bits. And I just don't understand why they put them on so tight. I'm not sure if there's Loctite or something else. No, it doesn't look like there's Loctite. I think it just, these machine screws are very tightly fit, and they are probably not designed to be opened up again. And you can see here, I had stripped some of these screws here already and not able to open it up. So I guess I have to save that for another day. And if you can see through the holes, you'll see that probably the teardown won't be that useful anyway, because it's just using some TL494, and I can already see the chip underneath there. So these are just your run-of-the-mill power supplies, very similar to some of the other ones I have already done teardown for. But from what I have demonstrated in this video, you can actually see this is a pretty decent power supply, and definitely something I don't mind having in my lab. Anyway, I hope you enjoyed the video. If you liked the video, please remember to give it a big thumbs up, and don't forget to subscribe to the channel for more videos like this in the future. Your participation makes videos like this possible. Thanks for watching, and I will see you next time.